x. And so when this thing is in a static situation, remember how we talked about the static frictional force? It has a value that is dependent upon the opposing force, right? So remember, like if I push on this with 5 newtons, the static frictional force is 5 newtons. If I push on it with 10 newtons, the static frictional force is 10 newtons. And so as I increase this angle theta, this component of the weight begins to increase, and this component of the weight begins to decrease. Right? So the static frictional force will increase because this is increasing. But something else is happening here. As I increase the angle theta, what happens to the minimum static frictional force? So remember, the static frictional force was less than or equal to, or I guess the maximum static frictional force. What happens to that value? So what happens to the maximum value that Fs can be as I increase the angle theta? Why does it decrease? You're right, but why does it decrease?
Because the cosines are making a decreasing function.
Okay, the cosine, right, but Michael, why does it decrease? I don't know, it just makes sense that it would decrease. It does make sense, but like according to this equation, u is not changing, so why is this decreasing?
And the natural force can be less.
Right, the normal force is decreasing. Right, so as I move this inclined plane up, the component of this weight increases, but the component of this weight decreases, right, the y component, and the normal force is equal to the y component of the weight. And so if this component decreases, that means the normal force is going to decrease, which also means that the static frictional force is going to decrease. All right? So the frictional force will increase, right, because Fwx increases. However, the maximum static frictional force will actually decrease because Fwy or the normal force, those are the same, are going to decrease. Let's work through an example. Here I have a block, an inclined plane, and your test will have an inclined plane on it, although it won't be exactly like this. It'll also have a second body. And if you look back, we'll work through a problem next, an old test question. It'll be similar but different, where you have 2 bodies that you have to deal with. We've already done one problem where we have to have 2 bodies, and so we'll wind up with 4 equations. But let's go ahead and work through this first. I want to just know I have a block that's sitting on an inclined plane, and I want to know what is the coefficient of friction that will keep the block on the inclined plane. Now, I've already drawn the forces here for you. Let's give this an angle. I'll call this 30 degrees. I don't think that's in your book. But if I have an angle of 30 degrees, hey guys, what is the coefficient of friction that will keep the block on the inclined plane? I've already done step 1. Actually, I've done step 1 and 2. That's where you label and identify all the forces. I've labeled the normal force, the weight, and the static frictional force. I've also selected the coordinate system on an inclined plane. The coordinate system is with the x coordinate along the plane of the incline. Now your next step, draw a vector diagram, then resolve the vectors into their x and y components, and then apply Newton's second law. I'll go ahead and redraw this. resolve that weight into its x and y components, and then you want to apply Newton's second law in the x and the y directions. I'm going to go to the next page. I'm going to go ahead and resolve those vectors. So my normal force, the static frictional force. Here I have the weight in the y direction. That's equal to Fw, what is it? Cosine or sine or tan? It's sine, right? Sine of 60. Remember, you're taking 90 minus the angle of the incline. And this is Fwx, which is Fw cosine of 60. And then from that, you can write two sets of equations. You can say that the sum of the forces in the x direction equals max. And you can also say the sum of the forces in the y direction equals may. I want to say there are two problems applying Newton's laws on the test. If you came in right, there are 4 problems on the test. I want to say there are 2 that are Newton's laws problems. One's a little more complicated than the other. But any Newton's laws problem, you're going to take it up to this point. You're going to write the equation. It's going to be exactly the same steps all the way up to this point. So where you're just writing your equations, let's see. So sum of the forces in the x is Fw cosine 60 minus Fs. And that's equal to 0 because my acceleration is 0. And then I have Fn minus Fw sine of 60. And that's equal to 0 as well because my acceleration is 0. Right? And I want to know what is mu. So the original question asked, what is mu? Mus. How will I go about finding the coefficient of static friction?
Did you set Fs equal to Fwx?
Right, so I can take this. I know what Fw is, right? It's 100 newtons, 10 kilograms times 10 meters per second squared. So I can find Fs. That's right, Courtney. And then what? Right, so my Fs is equal to mu s times the normal force. So mu s is equal to Fs over the normal force. So if I know Fs and I know the normal force, then I can find mu. So I find Fs from the x equation. I know that mu is the ratio of those two forces. How do I find Fn? What's that? Right. Okay. So I can find Fs here. Fs is equal to 100 cosine of 60. And then Fn is equal to 100 sine of 60. Alright, that's going to be 50. This is equal to 90. And so mu is equal to 50 over 90, which is, you know, roughly 0.5. I don't know what it is exactly. You alright? Follow that okay? Yeah? Okay. Alright, let's do another problem. That'll be more like what you'll see on the test. So you could see a problem like this. I don't know if I brought the test with me. I didn't bring it with me. I think I had a simpler problem and then a more complex problem on Newton's laws. Let's skip this. We'll come back to this. I want to work this next problem. Here I have 2 bodies. Have we done one similar to this? You did, right. This is a lot like the lab. We did a problem previously. I just want to make sure it's not a repeat of this. Otherwise, we'll do something else. No, this is the one we did, isn't it? Okay, let's try this problem. And then we'll go back and do that clicker question. Actually, let's do the clicker question first. Alright, so let's try this first. Okay. Alright, so this one you just want to find the normal force. Now hopefully by this time you've done enough inclined planes either in class or in the homework that you can just look at this and without writing out all the equations, you can tell me what is the normal force, hopefully. Because we know it's equal to the y component of the weight, and you know how to find the y component of the weight, I think. Alright, let's see, 3, 6, 9, 11, 14, say 125. 5 more seconds, just guess, don't know. Okay. It's the problem we just worked, right? Did y'all recognize? They were the same numbers, okay, good. Well, it's good practice anyway. So, I have my weight here. My weight is broken up into a y component and an x component. And the normal force is there. The normal force is going to equal that y component of the weight. And that y component of the weight is equal to mg times the sine of 60 degrees, which is equal to 100 sine of 60, which is equal to 80, it's actually 87 newtons. This problem, when I wrote it, I was using 9.8 as g, but if you use just 10 as g, you'll get 87. Alright, and then try this. Well, we just did this. I'm going to skip this next one. What's that?
In the next quick test, I said that would be sweet until that actually signifies.
I'm sorry, what?
See, you can find a minimal step fraction as 0.5 and A, D, E.
Oh, right. No, if your coefficient of static friction is less, it's not going to have enough force in order to hold it in place.
Or, no. You find the minimal fraction. Minimal fraction, just like this question, and is the minimum fraction, U is 0.5.
Right, 0.6 is the answer to this one. 0.58.
And T is also is more than 0.5. And E?
Oh, D. Oh, yes.
A, B, D, they're all correct. I mean, just explain them.
Oh, I see. You're saying A, B, or D.
Yeah.
I don't think that the coefficient of static friction can exceed 1. Is that true? I'm not sure if that's true or not.
Yeah, and maybe that's...
Is it, can it exceed 1? No, I don't think it can.
Oh, that's something I haven't told you about.
I haven't said that, have I?
Yeah.
Okay. Alright, we're going to skip this one. It's not really pertinent to y'all. Alright, let's try this. Alright, on this question, the first thing you want to do is label all the forces. And here we have 2 separate bodies that are moving. So you're going to label the forces on M2, and you're going to label the forces on M1. You'll have a problem very similar to this on Monday, where you'll have 2 separate bodies that are moving. So label the forces on M2, and label the forces on M1. Then you want to draw your coordinate systems for both. They will have different coordinate systems. And then you want to resolve the vectors. In this case, you'll just be resolving vectors for M2. And then write the 4 equations that govern the motions for both of those coordinate systems. Actually, you'll just have 3 equations. let you get a little head start, and then I'll jump in. I'm going to start labeling the forces here. Once you do that, you'll want to resolve. You only have one vector there, that FW2. Resolve it into its x and its y components. I always find it helpful to draw new vector diagrams. You might find that helpful, you might not. And then write out your system of three equations. You know, three equations that you can write from these two systems. Coming along okay? Once you get to this point, you might want to redraw this over here, rotating that coordinate system and resolving that vector into its x and y components. I'm going to go ahead and do that now.
One of the problems that we're dealing with is acceleration in the x direction, right?
This one is accelerating in the x direction, actually. So, does that answer your question?
Yeah.
And on the test, very likely it will have an acceleration. At least one of the problems. You still work it the same way. Just makes it the algebra a little more complicated. Oh shoot. Now you want to write your system of equations. You'll have an equation here describing the motion in the y direction. You'll have an equation concerning these two variables, the motion in the y direction, sum of the forces in the y equals MAY, and then you'll have an equation for this system, the sum of the forces in the x. Now, what you want to be careful with here is that you very clearly keep your masses separate, because M1 and M2 are different. So FW1 is different from FW2. So when you write out your equations, be very clear that you get your subscripts all correct. Often students make a mistake with that. They just don't track their subscripts carefully enough. And then also you want to realize a couple of things, is that the tension in the rope here, how is it related to the tension in the rope here? They're equal. So if you ever apply a tension, assuming that the rope doesn't stretch, if you apply a force to one end of the rope, you feel that same force all the way throughout. So the tension there is equal. And another little trick that we'll use is the acceleration of this block is bigger, smaller, or the same as the acceleration of this block? It's going to be the same. If our rope doesn't stretch, right, if it's, what's the word? Taut. I don't think that's the word I'm looking for, but yeah, if it's taut, if it doesn't stretch, I think there's a technical term for not stretching. What is it? Inelastic. Thank you. Yeah, if it's inelastic, then the acceleration of M1 will equal the acceleration of M2. All right, so those are a couple of things we want to keep in mind. I'm going to go ahead and write out the equations. Hopefully you already have them. I'm going to start with this set. It's going to be Ft minus Fw1 is equal to M1 times A. And I'll just write it as A because I know that A1 will equal A2. And then I'll write this one. I have Fk plus Fw2 cosine 60 minus Ft equals M2A. And be very careful about my subscript there because it's a different mass from M1, and that'll make your answer different if you get those incorrect. And then Fn minus Fw2 sine of 60 is equal to 0 because it's not accelerating in the y direction. So now I have this system of 3 equations, and then I have several things that I've asked you. In fact, these questions, A, B, and C, sort of lead you through the problem. First, what is the normal force acting on block 2? That's the block on the inclined plane. I can find here Fn equals Fw sine 60. Yeah.
So A is actually inclined, right? So the switching should be like
A.
The switching is actually
Up the inclined plane?
yeah. So actually, the tension force should be tension force minus flexion force minus.
Oh, I see what you're saying. Yeah. So our acceleration. Wait, no. No, the way I've drawn my coordinate system, it doesn't matter actually. You could write it that way. You'll see what he's saying. He said that this should be Ft minus Fk minus Fw. That's what you're saying? Yeah. You're saying that it's up the inclined plane, which is true, but the way that I draw my coordinate system here, I've let my x-axis be along here, and so Ft now is in the negative x direction. But it doesn't matter, like you could do that. It would just mean that you're taking left to be positive and right to be negative.
It's more initiative.
It's okay, yeah, but the way that I've drawn the coordinate system, I'm going to keep it like it is. All right? It would change the sign of your acceleration in the end that you find. Right. Is our acceleration in the end, is it going to be positive or negative? It's going to be negative. The way we've drawn our coordinate system, on the inclined plane, it's going in the negative x direction, and on the block that's dropping, it's going in the negative y direction. So it'll be negative in both cases. All right, so Fn is equal to Fw sine of 60. That's Fw, look, I've already messed up, Fw2 sine of 60, which is M2, which is 2.1 kilograms times 10. Was it M25? Oh, you're right. See, this is what gets you on these things, is losing those subscripts. So you need to be very careful about that. And unfortunately, if you get the equations correct, I'll give you most of the credit. But if you make a problem in the algebra, then I'll count off. So it behooves you to make sure that you write these very clearly on any of these problems. Because once you get up to that point, I consider the problem almost completely done. Is that clear what I mean? If you can do up to that point, the rest is just algebra. 0.5 times 10 times sine of 60. What's that, 2.5? Oh no, sorry, 0.5 sine 60. 0.43 newtons. All right, so that's the answer to this first part, 0.43 newtons. And then I want to know, what is the frictional force acting on block number 2? Well, I can find that, because now I know the normal force, and this is equal to mu k times the normal force. What is the mu for this question?
I don't think it would be 0.43. It's 4.3.
Oh yeah, you're right. All right. What is our coefficient here?
You could use the normal force and multiply it by the given mu k to find the coefficient.
Right. Yeah. What is our mu k? It's 0.4. Yeah. So it's 0.4 times 4.3, and that's equal to 1.7 newtons. All right. So that's part B. And part C requires you to solve a system of equations. So I'm looking now for the acceleration of block 2. Let's look at these two equations because these have our accelerations in them and see how many unknowns we have. I'm going to mark them with a question mark. I don't know what the tension is, and I don't know what the acceleration is. In this second equation, I don't know the tension, and I don't know the acceleration. So in both of those equations, I only have two unknowns, and they're the same unknowns. So we can solve that system of equations. You can solve it by substitution. You'll solve one of the equations for one of the variables, and then substitute that into the other. Let's see. I said Ft is equal to Fw1 plus M1A. And then I substituted this in here. And then I solved that for A. And that looks like this. I'm not going to work through all the algebra, but when I substitute that in, I get Fk plus Fw2 cosine 60 minus Fw1 plus M1A equals M2A. All right. I know most of these values, everything but the acceleration. At this point, you could put in numbers here if you like, and then simplify it, and then solve for A. I'm going to leave it there, though. If you follow this through to the rest of the algebra, several steps, you find I have negative 11, that the acceleration equals negative 11. No, that can't be right. Is it 6.4? Yeah, 11 can't be right. That's too fast. Let me make a note here. All right. Why do I know 11 is too fast, by the way? Because this thing in free fall, the one that's over here, isn't going to fall. If it was in free fall, it would fall at 10 meters per second squared. All right, but I actually have a force that's holding it back. Okay? You can follow that algebra the rest of the way and solve for A. On the test, something similar to this. It's not going to be like this, but it will incorporate forces that are not on axis, on an inclined plane or otherwise, and then it also incorporates two bodies. And as I said, I think there's another problem that just has one body, a simpler Newton's laws problem, laws of motion problem. No good on this? There are several examples in the old test. I would go through and work through those, though the one on your test will be different from all those, but similar. Okay, let's do the concept test, the remainder of those. But first, are there any questions about the test? Any burning issues? Projectile motion, vectors, vector addition, and Newton's laws. That's what it would be. Yeah. 15 multiple choice, 4 free response. 70 points for free response, multiple choice, 30 points. Just like that. 7:15 or 6:30 if you want to get it at 6:30. 7:15. What's that?
Around 6:30.
Oh yeah. Okay. I have to do this one. All right. Any questions? Feel comfortable? You take it right now and make a C on it? Maybe? You don't want to see. I had a friend in college, and whenever we took tests, he was a physics major, whenever we took tests, he would say, C is for cookie, that's good enough for me. Like Cookie Monster, right? He used to say that. That was his mantra. C is for cookie. All right. Does anybody know where we left off here?
4.1D.
That's right here. So we.
Are we done that this week? Yeah.
Okay. So have a card on a frictionless table. Give it a push and release. What will happen to the cart? Alright, I'll stop at 35. We might not do all these. I might skip over some. There's quite a few left. I thought we'd done more than this. Alright, D is right. Newton's first law, object continue in motion unless a force acts upon it. If it's a frictionless table, then it doesn't have any forces acting on it. What would have to be done to the same cart in order to give it constant acceleration on this table? Thanks, Zach. Huh? No, you're right. All right. I'll stop at 35. I always tell students that they can talk to one another, and I've always expected to have a student that would just on every question stand up and announce the answer to the whole class. But I've never had that. It would be allowable. That's allowed, but I've just never had that. We have 15 now? 3, 6, 9, 11, 14. Oh, I guess we're 15. Alright, a very large truck sits on a frozen lake. There's no friction between the tires and the ice. A fly smashes against the front window. What will happen to the truck? There are actually two appropriate answers for this, either B or C. But go ahead and put in B, because that's the answer I intended. So this fly smashes into this truck, and it exerts a force on the truck, and the truck exerts a force on the fly, right? Newton's third law. And that's going to cause the truck to accelerate just briefly as the fly is pushing on the truck, and then the truck will continue backward at a constant velocity.
This is something I want to see.
Yes. The difference is, right, that it's a purely frictionless lake, or a frictionless surface. And it would have to be, because the truck has such a large mass, it feels a larger friction because its normal force is greater. So B is the right answer. Just put in B. It's somebody in another class, I think. Or somebody sitting out in the hallway clicking in. Yeah, oh, yeah, let's see a joke. You want a joke? You need a joke?
Sure.
This is the only one I can think of, and it's kind of gross. Is that okay? Okay, knock knock.
Who's there?
Smell mop.
Smell mop.
Ew, that's gross. Sorry. I try not to tell that one. It's kind of gross. Alright, from rest, we step on the gas of our Ferrari, providing an F for 4 seconds, speeding up to a final speed V. If the applied force were only a half F, how long would it have to apply to reach the same speed? Get a certain speed with a force F in 4 seconds, apply half the force. How long do we have to apply it to get to the same speed? We're going to start from rest. Alright. I haven't stopped it yet. One more person there. D is right. If I have half F, so there are two things going on here. I have F equals MA, and v equals at. If I have half the force, that means I have half the acceleration. If I have half the acceleration, I need twice the time in order to get to the same speed. I'm going to skip this and go to this one. We'll have a question like this. It'll be something very similar to this on the test, a multiple choice question. Okay, not many of you are getting it right. I'm going to start stepping you through some of it, okay? Here, I have F equals M1 A1. For a given force, M1 gets an acceleration A1. Then M2 gets an acceleration twice that of A1. So what is M2 with respect to M1? M2 is what fraction of M1? It's what fraction of M1? It's what? No, it's not twice. It's 1/2 of M1. Right, so M2 with the same force gets twice the acceleration of M1. So that means it has half the mass of M1. All right. Now, if I put them together, M1 plus M2 is going to equal 3/2 of M1. Right? Because I have 1 and then a half of M1, so that's 3/2 of M1. So, if I come back up here, and I imagine that now I have 3/2 of M1, I have the same force, what acceleration am I going to get? In order to, if I have 3/2 of M1, I have the same force acting on both blocks, which are 3/2 of the original mass. What is my acceleration? Changing in the right direction, but still a lot of you have it wrong. If my force is constant, F, I have a 3/2 right here. What do I have to have right here for my acceleration in order to get it to be constant? I'm going to stop at 312. 312. He is right. I have to have 2/3 the original acceleration, given 3/2 the mass. All right, you have a multiple choice question. Just make sure you're ready for it. All right, I'm going to skip some of these, just sort of hit the hard ones. Let's try this one. Let's try this one. This elevator is accelerating upward. What's the relationship between the weight of the block in the elevator and the normal force? We're all over the board now. You have like equal answers for A, B, and C. Okay, we're accelerating upward here. I'm going to draw a vector diagram. I have my normal force, which is up, and my weight, which is down. If it wasn't accelerating, the normal force would equal the weight. So Fn minus Fw here equals ma. So Fn equals Fw plus ma. Right, here my acceleration is positive or negative? It's positive. I have a positive acceleration right here. So how is my normal force related to the weight? Is it bigger, equal, or smaller? All right, I'm going to stop at 155. 155. Now we're still split about half and half on the answer. A is the right answer. All right, if my normal force is equal to this, and this is positive because it's accelerating upward, that's going to be some value of the weight plus this extra value. So the normal force is going to be bigger than the weight. If it was accelerating downward, the normal force would be what? Like if this was negative, the normal force would be bigger or smaller than the weight? It would be smaller than the weight. All right? You okay with this? Rainy day? Is this the rainy day? It's the rainy day. Okay. I don't think it's supposed to rain on Monday, so that should be good. Okay, how about this one? I have two blocks. One's on a flat surface, one's on an inclined plane. For which case is the normal force greater? A, B, they're both the same. Equal to the weight, I mean. Both the same. Intermediate for the weight, or both the same, 0. All right, I'll stop at 112. 112. Who is that? Somebody have? Nobody has two clickers, do you? I'll find out. I can look at the roll. All right. Cool. All right, so let's see. A is correct. Let's get this. Is it okay if we skip a few more? Let's skip a few. Okay, anti-lock brakes keep the car wheels from locking and skidding during a sudden stop. Why does this help slow the car down? Why does an ABS system help your car stop? Here, sliding is referring to kinetic friction, and static, of course, is static friction. All right, I'll stop at 1 minute. That's right, D is right. Our mu s, our static frictional force, is usually bigger than the kinetic frictional force, and your ABS keeps your wheels from locking up, so they keep turning, and that allows for static friction to be at play. It's only when your wheels lock up and the tire slides across the road does kinetic friction or sliding friction come into play. Your little sister wants you to give her a ride on her sled. What's the easiest way to accomplish this? Push her from behind, pull her from behind, or are those equivalent? That is, which of these scenarios will give the least frictional force? To push from behind or pull from behind? Right, yeah. It's not E. A, B, or C. You want to find the scenario that gives you the least frictional force. The least frictional force. All right, I'll stop at 1 minute. 1 minute. And that's right. By pulling her from the front, that decreases the normal force because I get my normal force, which is this way, but I also get a y component of the weight, or excuse me, of the force. Excuse me, a y component of the force that you're pulling with, and there's my weight. So I would say Fy plus Fn equals Fw. So Fn is equal to Fw minus that y component of the force. By pulling up, you decrease the normal force. Whereas if you're pushing down, you increase the normal force. That's in general, whenever you're trying to push something on the ground, it's always better to pull up than pull it, because you decrease the frictional force. All right, I think we'll just stop right there. The concept test is already online, and there are solutions there also, or the answers are on there as well. I think we'll call it for today. 7:15. I'll be sort of around this afternoon. I have an exam at 1:30, so I'll be in that. Make sure you're up on your projectile motion, the problems that we did, and the problems in the homework and what have you, and then also on Newton's laws. That is the exam. But also, wrapped up in projectile motion on the conceptual stuff. Make sure you know your diagrams, your position and velocity versus time diagrams, like you did in chapter 2, and in the lab as well. All those things about hang time and how long the object is in the air. Newton's laws, first, second, third laws. All right. I think y'all be okay. Have a good day, okay?